Types of optical fiber. So what criteria should we consider for optical fiber for a replacement of metallic cable in communication system? So there are few factors that we need to consider. It should be long lasting with invariable optical and transmission characteristics. It has to be possible to fabricate optical fiber with different characteristics such as relative refractive index, size, and operating frequencies. The connections between the fibers should be such that it produces least loss. It means the signal loss should be very less. From those factors, we can broadly classify the fiber in three categories. First one is based on the material, second is the mode of propagation, and the third is refractive index. So first is based on the material. We required two compatible transparent materials with different operating frequency. In addition, it has relative difference in refractive index. Means refractive index has to be different than two compatible transparent materials and must be able to transform in long, thin and flexible fibers, right? So in the current scenario, the suitable optical fibers are very limited. It is either glass or plastic. But if we use the plastic, it shows very high attenuation, means very high signal loss. That's why the glass is most suitable for the optical fiber. There are few reasons why we need to use a glass, right? So first one, it is gradually becomes stiffer with temperature variation, and this helps to transform into thin fiber to desired thickness. That's why we use the glass. Pure silica exhibits extremely low loss and up to 96% transparency. Great intrinsic mechanical strength to create different to create difference in refractive index between the core and cladding. That's why we require two transparent material, right? But we can use the glass of different refractive index as a core and cladding. That is either fluorine or oxides are added such as TiO2, aluminum oxide, GeO2, P2O5, etc. Fluorine or oxides, which is added like titanium oxide, aluminum oxide, GeO2, P2O5, etc. in silica with silicon dioxide for creating a different refractive index. Or like plastic core with plastic cladding, glass core with plastic cladding, glass core with glass cladding. Second one, based on mode of propagation. Before we discuss different type of fibers, we need to discuss the mode. different mode of propagation. So index profile, step index fiber, and graded index fiber. We know that the refractive index of the core and the cladding are different, and the cladding itself must have uniform refractive index, while the refractive index of the core may not or may vary as per the requirement. But for the cladding it has to be uniform refractive index, but for core it is may or may not as per requirement. Now what is index profile? So means index profile means the curve representing variation in refractive index with respect to refractive index of core with respect to the radial distance from the axis of the fiber is termed as index profile. So there are two types of index profile: step index profile, graded index profile. In the step index profile there is single mode, multi-mode, and other is graded index, that is also multi-mode. Let's understand one by one. So now as shown in the figure A, the step index fiber, the core has uniform. This core has uniform refractive index throughout the core radius and undergoes an abrupt changes at core cladding interfaces. Abrupt change in the core cladding interfaces. This type of interfaces. At the interface, the index profile is a step function. The step function. This type of fiber is referred as a step index fiber. There are two type of step index fiber: single mode step index fiber, multi-mode step index fiber. So single mode step index fiber relatively narrow diameter. Narrow means in this mode or in the single mode means one mode will propagate typically 1310 or the 1550 nanometer. Single mode fiber has a much smaller core than the multi-mode. The small core and the single light wave virtually eliminate any distortion that could result from the overlapping light pulses, since it's a single mode, right? So this is very narrow and it is eliminate any distortion that could be possible due to overlapping light pulses, providing a least signal attenuation, means loss is very less in the single mode, and the highest transmission speeds of any fiber cable type. The single mode is highest transmission speed and least signal attenuation because of no overlapping light pulses, because of its very narrow diameter, right? The next one is step index fiber Second type of step index fiber is multimode step index fiber, in which fiber has a relatively large core of diameter about 50 to 100 micrometer with cladding diameter is 100 to 250 micrometer. This is core and cladding, this is cladding, and this is core, as shown in figure. As a result, some of the light rays that make up the digital pulse may travel a direct route, whereas the other zigzag as they bounce off the cladding. The zigzag bounce off the cladding. These alternative pathways cause the different grouping of light rays. These alternating, this will go and this will like go to alternating. These alternating pathways cause the different grouping of light rays, which we called as modes, to arrive separately at receiving point. The pulse, an aggregate of different modes, begins to spread out. Begins to spread out and losing its well-defined shape. It is required to leave spacing between two pulses. Leave spacing between two pulses to prevent overlapping limits. To prevent overlapping limits. Bandwidth. That is the amount of information that can be sent. So consequently, this type of fiber is best suited for transmission over the short distance in an endoscope, for instance. The multimode graded index fiber contains, this is the graded index fiber, multimode graded index fiber, contains a core in which the refractive index diminishes, decreasing gradually from the center axis outward, the cladding as shown in the figure. The higher refractive index at the center make the light rays moving slow down. Here, this is multimode graded index fiber. The higher refractive index pulses moving slow than those near the cladding. That's why rather than the zigzagging of the cladding, the light in the core curves is helically. This is helically because the graded index, reducing its travel distance. The shorten the path and the higher speed allow light at the periphery to arrive the receiver at about the same time as the slow but straight rays in the core axis. So light travels slower in the center, but light travels faster in the outer. This is outer and this is center. The result is less dispersion for digital pulses. This fiber can handle higher bandwidths and provide longer length of transmission. So higher bandwidth, longer length of transmission, and less expensive. This is see here, the single mode is more expensive as compared to here. This multimode, sorry, multimode gradient index or multimode graded index, right? This is also multimode. This is also multimode. This is for the short distance. This is for the long distance transmissions. Graded index multimode, step index multimode. Graded index multimode, step index multimode, single mode step index. Multimode fiber offers several advantages over the single mode fiber, such as easy connecting processor, low power source such as LED, and therefore less expensive as compared to single mode fiber. Okay, so what we learn, modes of operation, it is single mode, multimode step index, and multimode graded index. This is for the short distance transmission and this is for the long distance transmission. So why this curve is helical, the reason is given here. So your fiber optics is now over here.